In this video, we're having a look at division of algebraic expressions using a method called synthetic division. We won't be going through the justification for the process, we'll simply look at the steps that are involved. In the examples that we're showing, the divisors will be linear expressions, with the coefficient of x being 1 in both cases. To start the synthetic division process, the first thing we do is we set up a table of 3 rows, and the first row inside the table involves the coefficient of the dividend. So in this case we've got 1x squared, 11x, and negative 26 as the constant at the end. We can see that the divisor is a linear expression, and the value after the x is negative 2. We put the opposite of that value outside the table, so in this case 2, which matches the first row. We now start the division process, where our answer, or quotient, to our division problem will appear below the horizontal line in the table. And we commence the process by looking at the first column inside the table. We place a 0 below the 1, and then add those values together to get a 1 in the first column. The next step in the table is to go through and multiply the 2 on the left-hand side by the result of the first column, which is a 1. We can see those values here in pink. 2 multiplied by 1 is 2, and that entry goes into the second column. We then add the values 11 and 2 together to get 13. We now repeat the process from before, and we multiply the 2 outside the table on the left-hand side by the result of the second column, which is 13. That gives us an answer of 26. We now add the final column together, and we get negative 26 and 26 comes to 0. And that final entry tells us that there is no remainder. Our solution to the division problem is formed by the coefficients in the result of the table, in other words 1 and 13. So how do we interpret these values? Well, if we look at the original problem, we can see that the leading terms in the dividend are x squared and in the divisor x. And if we do a simple division of x squared and x, we know the result will be x. So that means that our leading term in the result of our table, which has a coefficient of 1, represents 1x. And the next value, 13, is the constant, and as said before, 0 is the remainder. So our solution to the division problem is x plus 13. Let's have a look at our second example, where we've made a slight change to the dividend and made it x squared plus 11x minus 30. So we repeat the process using synthetic division by setting up our first row of the table, which is the coefficients of our dividend. We can see here we've got 1x squared plus 11x minus 30. We then consider the divisor, in this case x minus 2, and we place the opposite of the negative 2 outside on the left-hand side of the table. So we have a value of 2. Again, we repeat the first column. We place a 0 below the 1, and we add up the 0 and the 1 to get a value of 1. This forms the first coefficient of our solution. We then use the numbers in pink, the 2 and the 1, and multiply them together to get the entry in the second column below the 11, which is 2. We sum the 11 and 2 to get to 13, and then we multiply the numbers in pink, which are 2 and 13, to get the value in the third column, which is 26. We then sum the negative 30 and the 26 to get negative 4. Now that negative 4 previously was a 0, so this time we do have a remainder of negative 4. So our solution is based on the coefficients of 1 and 13, which gives us an actual answer of x plus 13, and we have a remainder of negative 4. We can express that algebraically by saying the division is equal to x plus 13 plus negative 4 over x minus 2. We can simplify that second fraction so it becomes x plus 13 minus 4 over x minus 2.